Now let us see how to find the angle between given two vectors. Suppose they give you vectors in terms of ijk, something like this. K, and B is another vector, some I minus j plus 5k. And they are asking you to find the angle between these given two vectors. Fine. You all know dot product of two vectors A dot B is given by mod A mod B cos theta, where theta is angle between A and B, and that's what they are asking us to find right now. Is it clear? So you know from this definition of dot product, what is cos theta? It's going to be A dot B by mod A mod B. This comes fine. So mod A mod B. So with theta is the angle between A and B. Fine. In this case, you already know how to get A dot B if these are the two vectors A and B. Fine. So what is A dot B here? You know I, J, J, K, K. I mean I dot I, J dot J, K dot K is 1, all else is 0. So when you are taking the dot product between given two vectors, you need to dot only I with I, J with J and K with K. Fine. So this is, okay, 3I dot I dot I is 1, 3 into 1, 3. Fine. So 3. Similarly, minus 2 into minus 1 is plus 2, J, J is 1. And here 1 into 5, 5, K dot K is 1. So plus 5. So this is going to be how much? 10. So A dot B is 10. And now comes mod A and mod B we need to compute. You already know this is the vector A. So what's going to be mod A? You know very well, root over, if it is xi plus yj plus zk, it will be root x squared plus y squared plus z squared. So here it's going to be root over 3 squared, that is 9, plus minus 2 whole square is also plus 4 only, and this is plus 1 squared, 1, fine. So mod A is going to be root 14, fine. This is 1 plus 9, 10 and 4, 14, fine. Similarly, now we need to compute mod B. What is mod B? So root over 1 square plus minus 1 whole square is again 1 square only, fine. So 1 squared plus 1 squared plus 5 square is root 25. This is going to be root over 27. So here mod A mod B will become root 14 into root 27, fine. So whatever value you can compute it and simplify. So this way you will get theta equal to cos inverse of whatever value you are getting there. So okay, so root 14 into 27. So this is the way how you get the angle between given two vectors A and B. I have chosen random values for the vectors, so we are getting some random angle. Fine. Is it clear? So this way you get the angle between given two vectors A and B. Mind you, sometimes they'll tell you if theta is the angle between these two vectors, then find sin theta. Okay, even if they ask you to find sin theta, it is convenient to go by dot product rather than cross product. You know, computing cross product is more tedious than this. Okay, so computing cross product is a bit complex than scalar product. Moreover, there you get a vector, you know, something like mod A mod of A cross B is mod A mod B sin theta. Fine, you get only the magnitude. So sin theta will be what? A mod of A cross B by mod A mod B. That means first of all you need to get A cross B, then you get its magnitude, then mod A, then mod B, it's lengthy. Okay, so you can avoid this, and even if they ask you to compute sin theta, you can find out cos theta only. And when you know cos theta, you know very well, this is cos theta suppose you are getting the value, say cos theta equal to some 1 by 5. So you can write here 1 and here 5, and then this you know very well, under root this squared minus this squared using Pythagoras theorem, fine. So you can get this value as root 24, root 25, you know, minus 1. So that way you can get this, and then you can write sin theta is equal to, you know, root 24 by 5, something like that, fine. Is that clear? So even if they tell you some two vectors and they ask you to find sin theta, where theta is the angle between A and B, you need to compute cos theta, then draw a simple triangle, and using your simple trigonometric ratios you can compute the value of sin theta, fine. So now you already know how to get the angle between given two vectors A and B. If A and B are two vectors, then angle between these two vectors is obtained by the formula cos theta equal to A dot B by mod A mod B. Mind you, this is by the definition of scalar product or dot product, fine. So this way you can get the value of angle between given two vectors A and B, fine. Now if they ask you what angle a particular vector is making with x-axis, or y-axis. They'll give you vector in terms of ijk. Suppose like I'll take a simple vector a equal to 3i plus 4j plus 5k, and now they're asking you to find the angle this particular vector makes with x-axis, or they'll ask you what angle this particular vector makes with y-axis, or what angle this particular vector makes with z-axis with respect to given coordinate system. Of course, rectangular right hand coordinate system. Fine, that's what we are using. Now you know very well, of course, on this board I can draw only 2D vectors, but you can visualize all that. Fine. This is positive x-axis, this is positive y, and positive z is out of the board towards you. Fine. Okay. Now they're asking you what angle this particular vector makes with x-axis. You already know how to find the angle between given two vectors. Suppose if they give you two vectors a and b, how will you get the angle between these two vectors? You will find out like cos theta equal to a dot b by mod a mod b, where theta is angle between a and b. Is it clear? This is the way how you get the angle between given two vectors a and b. Fine. And now suppose this vector a is somewhere here. Of course, this vector is not in the plane of the board. I can't draw out of the plane, so I'm drawing here. Fine. So suppose this is vector a, and they're asking you what angle this particular vector makes with x-axis. Okay, angle vector a makes with x-axis theta x, I'll call it alpha. And angle vector a makes with y-axis theta y, I'll call it beta. Angle vector a makes with z-axis, I'll call it gamma. Fine. So now this is suppose alpha, this x-axis and this vector a. Of course, it is a three-dimensional vector, but I'm showing just the 2D part of it. Of course, the 2D part of it is not this whole thing. I can't draw it out of the board, that's why I'm showing it like this. Fine. 2D part of it is going to be this much. This is x-axis, this is y-axis, so this will be 3i plus 4j if you consider it that way. But I'm not drawing in xy plane. Mind you, I'm assuming this is the whole vector out of the board. This angle they want. If it's out of the board like this, it's not in the plane of the board, out of the plane of the board, this angle alpha they want. Is it clear? Hope you're understanding what I'm trying to tell you actually. Fine. Now, do you know any vector in the direction of positive x-axis? Any vector in the direction of positive x-axis? Can you name it? Any vector in the direction of positive x-axis? Any vector? Do you know? Obviously, I. Fine. So you all know I is a unit vector in positive x direction. Now, whatever angle this particular vector A makes with I, that's nothing but the angle vector A makes with x-axis. Is it clear, everybody? And you already know how to find the angle between given two vectors. How do you do that? Cos theta equal to a dot b by mod a mod b. Say this A is one vector and another vector for B you need to take I. You know it very well, whatever angle this vector A makes with x-axis is nothing but whatever angle vector A makes with x-axis is nothing but the angle vector A makes with I. Is it clear? So whatever angle this vector A makes with I is the angle vector A makes with x-axis. That's what they want. Fine. So instead of B, you are going to take here what? Obviously I. Okay. So now A dot B by mod A mod B. So this is going to be the angle vector A makes with x-axis cos theta x. Is it clear? So now you all know very well what is this. So a vector A is given as 3i plus 4j plus 5k, okay, and dot b. Okay, what is this b? Another vector is nothing but I. So a dot I by mod a mod b. Fine. So here how to compute mod a? I'll show you the trick. Anyway, it is 3 4 5 5 5 5 root. I'll write here directly, but later on I'll show you anyway. It is 5 root 2 and not 5 root 5, sorry. So, and mod I, you know it very well. This is mod A I have written, mod I is going to be 1, fine. Now I need to compute A dot B. You know very well, only II, JJ, KK, when you are dotting, they are going to be 1, all else are 0. So when you are dotting I, you can dot only with I, fine. So 3I dot I is going to be 3, I dot I is going to be 3, I dot I is 1, 3 into 1 is 3, that's all. You know very well, J dot I 0, K dot I 0, so you don't have to consider those things, straight away only these things. And here it is 5 root 2, so this is going to be cos theta x, or I will call it cos alpha, where alpha is the angle vector A makes with positive x-axis. Is it clear, everybody? Now let us see what angle this vector A makes with positive y-axis, this angle beta. Fine. So now you know, do you know any vector in positive y direction? Obviously J. You need to compute now the angle between vector A and J. That will be the angle vector A makes with positive y-axis. So that's, I'll write here cos theta y equal to A dot J by mod A mod J. Fine. A dot B by mod A mod B. Is it clear, everybody? So you already know this. So I would have written here itself, but I need to repeat all this. Okay. So now dot J by mod A mod J. Mod A we already computed, it's 5 root 2, and mod J is 1. You already know this. So this, now you know you need to dot here you have only J. So you need to dot only J with J. Fine. J term. Rest of the terms anyway will become 0. So 4J dot J is going to be 4. And by 5 root 2, this is, I'll call it cos beta, where beta is the angle vector A makes with positive y-axis. Is that clear, everybody? Now let's find out what angle this vector A makes with z-axis. Fine. So with z-axis, I mean this is out of the board. Z-axis is towards you, positive z-axis, and the vector is somewhere here. So they want this particular angle. If this is z-axis out of the board, this vector A, they want this angle. Fine. This angle. This is vector A, this is z-axis towards you, they want this angle vector A makes with positive z-axis gamma. Fine, I'll call it gamma, or I'll call it cos theta z, fine. Now you know it very well. Do you know any vector towards positive z-axis now? Obviously K, so it's going to become, for other vectors A dot K you need to take, fine. So you need to compute the angle between A and K. So A dot K by mod A mod K, and this is going to be obviously 4A, I'll write 3I plus 4J plus 5K, and dot K as it is by, you know, mod A mod K. Mod A already we know it's 5 root 2, mod K is also 1 because the K is also a unit vector. Fine. But now you know K means you need to dot only with the K term. Is that clear? So that's going to be 5K dot K is going to be 5 by 5 root 2, and that's going to be 1 by root 2 obviously, and this 1 by root 2 I will call it cos gamma. Clear, everybody? This cos alpha, cos beta and cos gamma are called direction cosines of vector A. Is it clear? And you know, if alpha, beta, gamma are the angles vector A makes with x, y and z axis, then cos alpha, cos beta, cos gamma are known as direction cosines of vector A, and cos square alpha plus cos square beta plus cos square gamma is going to be 1. Fine. In this case you can check it for with this particular example, but it is true for any vector. Fine. So now you see in this case you have the vector 3i plus 4j plus 5k, and cos alpha we are getting 3 by 5 root 2, cos beta 4 by 5 root 2, cos gamma 5 by 5 root 2. Fine. That is 1 by root 2. Just try to see what is cos square alpha. Square of this, that's going to be 9 by 25 into 2. Clear? This is 9, square it, 25 into 2, fine. This is going to be 4 square, 16 by 25 into 2. 16 by 25 into 2, that is 50 anyway. And this 1 by 2, you know, you can square and write 25 by 50, fine, or 25 by 25 into 2, fine. So this is 25 by 25 into 2, 50. You can take LCM as 50, and when you add up in the numerator you have 50, and that is 1, fine. I am showing for this specific example, but it is in general valid for any vector. Fine. Is that clear? And sin square alpha plus sin square beta plus sin square gamma is going to be 2. Okay. You know very well sin square theta plus cos square theta is 1. Okay. So this cos square alpha can be written as 1 minus sin square alpha. Using that formula, sin square alpha plus cos square alpha equal to 1. Fine. Similarly, this cos square beta can be written as 1 minus sin square beta. And this can be written as 1 minus sin square gamma, which is 1. And now you can take this 3 terms other side, they'll become positive, and this 3 1s will remain this side, that is 3, and minus 1 will be 2. Fine. You get sin square alpha plus sin square beta plus sin square gamma equal to 2. Is that clear? Where alpha, beta, gamma are the angles vector A makes with x-axis, y-axis and the z-axis respectively. Clear, everybody? Mind you, I'm not telling direction cosines are unique for a given vector. In fact, all vectors in same direction will have same direction cosines. All vectors in same direction will have same direction cosines, right? For example, if you have this vector 3i plus 4j plus 5k, or if you multiply this vector with say 5 or 2, you would still get the vector in the same direction now. Like for example, this particular vector A, I'll just multiply it by positive number. You know very well, when you multiply a vector by a positive scalar, you will get another vector in the same direction. So now this vector, we are multiplying the whole thing by 2 and you will get what? 6i plus 8j plus 10k. Even this vector will have the same direction cosines. I mean cos alpha, cos beta, cos gamma will have the same values, that is 3 by 5 root 2, 4 by 5 root 2 and 1 by root 2 respectively. You can check it for yourself, compute it like this, a dot I by mod a like that, fine. For a now, instead of taking a, you take it this 2a, you call it b, and you take it this b, no problem, fine. Instead of a, now you take it b vector, which is 2a, and you would still be able to get here. Remember, b is nothing but 2a, so you will need to multiply the whole thing by 2, okay, whole thing by 2, fine. But remember, when you are multiplying this, even mod a, in this mod a you will get the magnitude of vector a multiplied by 2. Ultimately these 2's will get cancelled and ultimately you will have the same values for cos alpha, cos beta and cos gamma. You can check it independently, fine. So what I am trying to tell you is, whatever be the positive number you are multiplying, whether it is 2, 4, 3, 1, as long as it is positive, no problem, because when you multiply a vector by a positive scalar, you would still get a vector in the same direction. So what I am trying to tell you is, any number of vectors, in fact infinite number of vectors which are all in the same direction will have same direction cosines. In fact, direction cosines give you a direction of a vector with respect to given x, y and z axis. Like how a vector is oriented, if you take tail at the origin, how that vector is oriented in three-dimensional space. If you take this as x, this as y and this as positive z, then 3i plus 4j plus 5k, how it is going to be oriented in three-dimensional space, that idea it gives you. This cos alpha, cos beta and cos gamma. They give you the idea in what way the vector is oriented in this three-dimensional space. Is it clear? Mind you, why do we prefer direction cosines rather than direction sines? Normally we don't prefer taking direction sines. We generally take direction cosines to get the direction of a vector rather than direction sines. Of course, if alpha, beta, gamma are the angles vector A makes with x, y and z, we say sin square alpha plus sin square gamma plus sin square beta is 2. But normally we compute cos alpha, cos beta and cos gamma, and we call this as direction cosines. We don't prefer direction sines. Reason is simple. You know very well. When you might be knowing simple trigonometry, all silver teacups, fine. And you know very well, sin theta is positive in both these quadrants. See, if you get the value of sin theta as half, can you confidently tell that theta must be 30 degree? Definitely not. So you know it very well, sin theta and sin 180 minus theta will have the same value. That means sin 30 as well as sin 180 minus 30. That is sin theta and sin 180 minus theta. They both will have the same value. And definitely in this case, when theta is 30 degree, this 180 minus 30 is going to be 150. So sin 30 and sin 150 both will have the same value of half. So if you get sin alpha as half, can you guarantee that the angle vector A makes with positive x-axis is 30 degree? No, it is quite possible it might be 30 degree or 150 degree. So it doesn't give you the unique value of the angle. Whereas when it comes to direction cosines, you know they are positive, cos theta is positive from only 0 to 90 degree, and then in the second quadrant cos theta is negative, fine. If you are getting cos alpha as half, you can safely say it must be, cos 60 is half. So you can safely say angle vector A makes with x-axis is plus 60 degree, okay? And when it comes to the other thing, cos 180 minus alpha, mind you, cos 180 minus alpha, cos 180 minus 60 is cos 120, and cos 120 is not half, it is minus half, you all know it very well. Cos 180 minus theta is minus cos theta. Is it clear? So you can safely say it is making 120 degree with x-axis, if it is minus half, and if it is plus half, you can say it is making 60 degree. Like that, direction cosines give you unique values of the direction, right? You can ascribe a unique direction to a vector when you go by direction cosines. But when you go by direction sines, you don't get the unique direction for a given vector. Is it clear? So we prefer direction cosines rather than direction sines. Now you might get the doubt like, of course, all silver teacups, but then here cos is negative. But I already told you, when you are computing angle between the two vectors, we need to take angle between 0 to 180. That is the convention. So I am just bothered about from 0 to 180, and here cos theta will give you unique direction of a vector. So we prefer direction cosines rather than direction sines. Is it clear, everybody? We will have a little more discussion about relative velocity. We have already seen velocity of body A. Velocity of body A relative to B is what? Obviously VA minus VB. Fine. Okay? And obviously velocity of B related to A is going to be VB minus VA. Fine. You know, when we say velocity of A related to B means velocity of A as in by B assuming B at rest. Okay? And we have already seen a velocity of boat related to water is same as velocity of boat in still water. Fine. Now, in some of the books, because you will be following some books for this competitive exams, engineering and medical entrance exams, and you will find they'll tell if this body is moving with V1 towards east, let's follow some direction convention here. This is, then this is north. So if the body is moving with velocity V1 towards east, and another body is moving with velocity V2 towards west, I mean in opposite direction, they'll tell relative velocity will be V1 plus V2. And if they are moving in the same direction, then relative velocity is going to be velocity of first body relative to second body. Velocity of first body relative to second body, they'll tell it is V1 minus V2. And if they are moving in mutually perpendicular directions with velocity V1 and V2, relative velocity is going to be root over V1 squared plus V2 squared. This is the way how they try to tell you. But actually, mind you, they are trying to give you the magnitudes of relative velocity. Okay? Whatever they are writing is correct in the sense that they are trying to give you the magnitudes of relative velocity. In all these cases, the basic definition of velocity of a relative is going to be VA minus VB only. Vector subtraction you need to do. Fine. And you know very well, when they are in opposite direction, VA minus VB will automatically become something like this. Fine. So suppose you know, in vectors, minus sign means opposite direction, right? So now let us see the first case when the two bodies are moving in opposite direction. If I call this direction as positive, then V1 will be positive and V2 is going to be negative. Okay, so now velocity of first body relative to second body. So what it is going to be basically now, we forget about all this, we'll just consider the first case, where they'll tell that when the two bodies are moving in opposite direction with V1 and V2, relative velocity becomes V1 plus V2. That's what normally it is written in most of the MSET or engineering entrance books. Fine. MSET, AEEE or other engineering entrance books, you will find this. Fine. So let us see how it is. See, velocity of first body related to second body. You know it is velocity of first body minus velocity of second body if you go by this definition. Okay. And this is nothing but velocity of first body. You know it is V1 minus, I mean if you want magnitude, okay, and what is V2? V2 is, you know, this is in this direction, so I'll call it minus V2, opposite direction. Fine. I mean if I want magnitude, so I'll write like this minus V2, so this becomes obviously V1 minus of minus will become plus V2. This is going to be the magnitude. Clear, everybody? Or if you know how to get the magnitude of the difference? Root over P square plus Q square minus 2PQ cos theta, where theta is the angle between P and Q. If you go that way also, you will get the same value, V1 plus V2. That will be the magnitude. I mean, in this case, formula is this only, but when you try to get the mod, you get V1 plus V2. That's what I am trying to tell you. Okay? Minus of minus, it becomes plus. Fine? So, it will be V1 plus V2. Magnitude will be this. Okay? Definition wise, it is this only, relative velocity. Magnitude if they want, it is this. Fine? Okay, if they want magnitude, it is this, V1 plus V2. Definition wise, it is general definition, V1 minus V2 will be the general definition. They might go in any direction they want. This is a standard definition for velocity of A relative to B, VA minus VB. They might go in any direction, random directions, no problem. You can still use this formula. But you need to take the vector subtraction. You need to get the subtraction, under root something like P square plus Q square minus 2PQ cos theta, where theta is the angle between P and Q, something like that. Fine? I'll show you by that method now. Like I'll try to get the magnitude right now. What is P square is V1 square, Q square is V2 square, minus 2P is V1, Q is V2, cos theta. Now you know very well, one body is moving this way and the other body is moving this way. So angle between the two velocities is 180. Cos 180 is minus 1. You know very well, minus of minus 1 will become plus. So this is going to be root, like a square plus b square plus 2ab. And you know very well what is this. Fine. This is nothing but a plus b whole square, like v1 plus v2 whole square, of course within root. So root and this square term will go. Just it will be v1 plus v2. Is that clear, everybody? So when both bodies are moving in the same direction with velocity v1 and v2, velocity of first body relative to second body. Once again the formula is going to be same. Velocity of first body relative to second body will be v1 minus v2, vector subtraction. Okay? And you know very well how to get the magnitude. Now the magnitude of the relative velocity is going to be v1 minus v2. Okay, we have already seen when they are moving in opposite direction, magnitude of the relative velocity will become v1 plus v2. Fine? When they are moving in the same direction, magnitude of the relative velocity becomes v1 minus v2. We'll see that root over p square plus q square plus 2pq cos theta. Mind you here, I should not use plus because I want difference. Relative velocity is difference of two velocities. So difference means I should use minus. Fine? So p square plus q square minus 2pq cos theta. And both velocities v1 and v2 are in the same direction. So angle between them is 0 and cos 0 is plus 1. Fine? And you all know very well what is this. This is nothing but v1 minus v2 whole squared within root. This is nothing but, fine. So magnitude of relative velocity of first body relative to second body, mod of this is going to be v1 minus v2 when they are moving in the same direction. Clear, everybody? So whenever some books write that when the bodies are moving in opposite direction, relative velocity will be v1 plus v2. When they are moving in the same direction, relative velocity is v1 minus v2. They are actually referring to the magnitude. Okay? If at all they were going to refer to the relative velocity vector, then it is this only, always. Irrespective of the random direction in which the two bodies are moving. Fine? Forget about opposite or same direction. Even if they are moving in any other angle with each other, even then relative velocity will be this only. Fine? Velocity of A relative to B will be this. Is it clear? Now, the same books will tell when these two bodies are moving mutually perpendicular to each other like this, then relative velocity's magnitude, they will tell it as v1 squared plus v2 squared. That you know it very well. By definition, it is again same thing. Velocity of first body relative to second body is v1 minus v2. Vector subtraction. Okay, and then if you try to get the magnitude of relative velocity of first body relative to second body, mod of this I want, and now you know very well how you do it. Subtraction to p square plus q square. Difference, remember, relative velocity is difference of two velocities minus 2pq cos theta. You know cos 90 because right now the two velocities v1 and v2 are at 90 degree. Cos 90 is 0 and this 0 into whole thing is 0, and automatically it is nothing but this term, that is root v1 squared plus v2 squared, which is nothing but magnitude of relative velocity when the two bodies are moving in mutually perpendicular directions. Clear, everybody? This is body A and this is body B, and suppose they are 100 meter away from each other initially. Okay? 100 meter away from each other, and these bodies are moving. See, suppose this velocity of A is in this direction, say 20 meter per second, and velocity of B, see this is in this direction, and velocity of B is say 30 meter per second, and it is in this direction. Fine, they are in opposite direction. Now you know it very well. This is the situation at t equal to 0, at t equal to 1, what the situation is going to be. You know, this body will travel 20 meters from here. See, this whole thing is 100 meters, so it will travel 20 meters, and this body will travel 30 meters. You know very well, total distance was 100 meters between A and B initially, out of which 20 meters is traveled by body A in 1 second, and body B will travel 30 meters in 1 second. So this is 30 and this is 20. You know, this 30, 20 put together, they are traveling 50 meters. So what is left out? Left out is again 50 meters. So mind you, initially at t equal to 0, A and B were 100 meters apart. 1 second later, this will travel 30 and this will travel 20. So 1 second later, they are just 50 meters apart from each other. So we can safely say the relative velocity between the two has a magnitude of how much? 50 meters per second. This is the relative velocity of A or velocity of A relative to B. Its magnitude, I should say. Fine? Okay? Velocity of A relative to B. Is it clear? I mean relative to each other. Together they are covering how much? It means that. Fine? As seen by one body, what it appears to the, see, this body A, suppose you are body A and B is your friend, okay? Of course, assume that you are in respective cars. Your car, you can drive with 20, suppose you are driving with 20 and your friend is driving the car with 30. Clear? Initially you will see that your friend is 100 meter away from you. After 1 second you will see that your friend is just 50 meter away from you, because you have traveled 20 and he has traveled 30. Forget about all that, who has traveled all the distance. But ultimately you will say that your car and his car are 50 meter apart. Or in 1 second you will say that, okay, your friend was 100 meter away 1 second before and now he is just how much? 50 meter away from you. So you will feel, you will assume that the fellow has traveled, as seen by you, related to you, he has traveled 50 meters. So magnitude of relative velocity becomes 50 meter per second. That's what when they say relative velocity becomes v1 plus v2, that is, it is becoming 20 plus 30. So in 1 second you are covering 50 meters together. So we say relative velocity's magnitude is 50 meter per second. Is that clear, everybody? Now let's apply this relative velocity concept to the velocity of the raindrops as seen by the person who is running on the road. Okay, suppose this raindrops are falling vertically with, see, velocity of the raindrops, V rain, it is say 10 meter per second downwards. Obviously, suppose the raindrop is falling vertically downward. Okay, I'm assuming VR, velocity of raindrops, 10 meter per second downwards. And you know very well, if this person is going to be at rest, if he is going to be at rest, is not moving at all, he will just see the raindrop falling like this with 10 meter per second, constant velocity. Okay, you will learn in chapter in fluids, you call it viscosity, you will learn that these raindrops are not going to accelerate all along the path as they are falling. Okay, they are going to fall with a constant velocity, you call it terminal velocity. Okay, they will not move down with a constant acceleration due to gravity. Due to air friction, they will acquire some constant velocity. And they will move with some constant velocity. And that constant velocity, of course, it depends on the sizes of the drops and all more details in the chapter viscosity. Right now, you should automatically assume these raindrops are falling with constant velocity. That constant velocity is called terminal velocity. Fine. So whatever it is, assume that raindrops are falling with constant velocity 10 meter per second. And this person is at rest. As seen by this person, these raindrops will definitely appear to fall down. Okay, he will see that they are falling in front of him like here. Clear? You just stand here and observe. It will appear raindrops are falling with constant velocity 10 meter per second. So that is the velocity of raindrops as seen by the man. Right now the man is at rest. And what if man is running? You know very well, when you are running like this, rain doesn't appear to fall vertically, even if it is falling vertically. Okay, you might have a very clear experience of feeling while driving a bike. When you're driving a bike, what happens? Raindrops will, normally when you stand and don't drive the bike, maybe they all appear to fall on your head and you'll get wet. The head will become more wet, fine. But then when you're driving a bike, which part of your body will get wet? The front part. Is it clear? Is it clear? The shirt in front will be more wet than the shirt behind you, fine. Is it clear? The part of the shirt behind you will be dry and part of the shirt in front will be wet because raindrops will appear to fall like this as seen by you when you are driving a bike. Is that clear, everybody? Now let us see what will be the velocity of raindrops as seen by this person if this fellow is moving in this direction. Okay, suppose this person is moving in this direction with a velocity, remember velocity of the man is say 5 meter per second. And velocity of the raindrops, I am assuming it to be 10 meter per second. Suppose this whole thing is 10 meter per second. And to understand the relative velocity concept, let us assume this particular raindrop is 10 meter above the ground right now. That means initially. And let this particular man is 5 meter away from this point where the raindrop is going to hit. Fine. Suppose this distance is 5 meter. And assume that this is, imagine the raindrop is here 10 meter above the ground and the man is 5 meter behind the point where the raindrop is going to hit. And the man is moving with 5 meter per second, raindrop is falling with 10 meter per second. Initially these are the two positions, you know very well. At the end, this is the situation at t equal to 0. This is the situation at t equal to 0. At t equal to 1, you know very well, in 1 second raindrop will cover this 10 meter and will be here, and the man will cover 5 meter and the man will be here. That means this raindrop is going to fall on the man. Is it clear? Hope you're understanding this. Okay, this man is going with 5 meters per second, the raindrop is falling with 10 meters per second, so at the end of 1 second this fellow will reach here and the man will reach here. Okay, and definitely raindrop will fall on the man. Is it clear? Now we want to compute with what velocity this raindrop will appear to fall as seen by this man. That means we need velocity of raindrop relative to the man. Is it clear? So you know very well velocity of rain relative to man. This is what we need to compute. Fine? This can be written as velocity of rain relative to man. That means minus Vm. You know very well. Subtraction means you need to negate it and then add it. Fine? So this is going to be the velocity of rain relative to man. Fine? So I need minus velocity of the man. This is the velocity of the man, but I don't need this. I need negative of it. Fine? I need minus Vm. This is minus Vm. This is minus Vm. Minus velocity of man. Of course, magnitude is phi only, but it is in this direction. Clear everybody? Fine. And now this minus V man, I need to add it to velocity of the rain. That will give you velocity of the rain relative to man, or velocity of the rain as seen by the man, assuming man at rest. Is it clear? That's velocity of the rain relative to man. Now you know very well, this is velocity of the rain, 10. This is minus Vm. This minus Vm I will add it to velocity of rain. Now see, tail, head, resultant, head, tail, third side in the reverse order. This is going to be the velocity of the rain relative to the man. Is it clear everybody? Fine. So as seen by this man, rain will appear to move this way. Okay. What I am trying to tell you actually is, related to the man, the rain is appearing to come and fall towards him. Reason is simple. This raindrop in 1 second will reach here, and this man in 1 second will reach here. So it's something like this. So this raindrop is going to fall on this man. And you know very well. Suppose imagine I'm throwing this pen towards you. Forget about gravity. Because in this case, even though gravity is there, it's moving with uniform velocity because the effect is being cancelled by air friction, I told you. So this is moving with uniform velocity and even this is moving with uniform velocity. Imagine this pen is moving with uniform velocity. Imagine that way. Fine. You know, if it's going to move with uniform velocity, it can't change the direction as well, right? It has to move in a straight line with constant magnitude of velocity. Fine. So suppose I am throwing this pen towards you. Don't you think it is going to hit you? You will feel that, oh, it's going to hit me because it's appearing to come towards you, right? Something coming with uniform velocity will appear to hit you only when its velocity is directed towards you. Is that clear? Suppose if I am throwing this pen towards you, do you think this girl will feel that the pen is going to hit me? Do you think this girl will feel that this pen will hit her when the pen is going this way? No. So a pen moving with uniform velocity will appear to hit you only when it is going to move towards you, or only when its velocity is towards you. Same way, now as seen by this man, you know very well, this man is going to go here in 1 second and this raindrop is going to come here in 1 second. So this raindrop, this particular raindrop is going to hit this man. And when this raindrop is going to hit this man, the velocity of this raindrop as seen by this man will be towards the man, because that raindrop is going to hit this man. Is it clear? Is it clear? Hope you are understanding it. So it will appear to this man as if the raindrop is coming like this. So you know, in this direction you will have the velocity of the rain, this particular raindrop as seen by this man who is running in this direction. So when the man is running like this in this direction, raindrop which is actually falling vertically as seen by somebody on the ground, for this man who is running on the ground, it will appear as if it is falling like this. Is it clear? Mind you, I repeat, this raindrop is going to hit the man. That's the reason this raindrop will appear as if it is falling towards the man. Okay? So this is one way I am trying to explain the relative velocity concept. So this is the velocity of the rain related to this man, as seen by the man. I already told you, velocity of rain related to man is same as velocity of rain as seen by the man, assuming the man at rest. Is it clear? Now let us try to understand this relative velocity that way. See, as we know, velocity of raindrop related to man means velocity of raindrop as seen by the man, assuming man at rest. And I already told you man is moving with 5 meters per second this side. Now, you know, velocity of raindrop related to man means velocity of rain as seen by the man, assuming man at rest. So its velocity should become 0. To make the velocity of man 0, what you need to do? This is already 5 is now. So you need to subtract 5 to make it 0. You need to subtract this in this direction, or you need to add this velocity to it. Okay? We need to add 5 in this direction. So it's going to become 0. But you know very well, whenever you are adding velocity 5 meter per second westward velocity of the man, same velocity you should also add to the velocity of the raindrop, because you know very well, when equal velocity is added to both the bodies, the relative motion will not change. Clear? So now same 5 meter per second towards west, I'll add it to the velocity of the raindrop. So now this is 5 meter per second and this is 10 meter per second. It's already having, remember now velocity of the man will become 0 because this is 5 and you are adding another 5 towards west, 5 east, 5 west. So now the man will be at rest. Now as seen by this man, raindrop will appear to have how much velocity? 5 towards west and 10 downwards. So put together, this is going to be 5 meter per second, this is going to be 10 meter per second. This value definitely will be, what is the common term here? 5. And here 5, you take 5 out and then its remaining term 1 squared plus 2 squared is going to be 5 root 5 meter per second. That's the magnitude of relative velocity of the raindrop as seen by the man, or velocity of raindrop relative to man. This raindrop will appear to come towards the man if the man assumes that I am at rest. If the man's velocity is supposed to be 0, then raindrop will appear to move in this direction. Is it clear, everyone?